Hi, good afternoon, class. Today we're going to be breaking down these lessons into several different parts for you all to understand the concept of the network layer. We're going to be doing some IP version 4. We're going to be doing some subnetting to bring to you knowledge of the networking layer. It's a very solid knowledge. So you all can understand how important this network layer is as it governs the whole aspect of your course in the whole area of networking as we move on. So first and foremost, we're going to look at the network layer communication. And we're going to begin our lesson by giving you a definition on an overview of what it means by the networking layer. That is about that networks. It talks about routing packets. We talk about the concept of the layer of the internet, otherwise known as the Internet Protocol or IP protocol. So basically, for your exam, they're going to be asking you questions in terms of what is the basic characteristics of the IP version 4. I'm only sticking with IP version 4 this time around. We will not be talking about IP version 6. The IP protocol is a connectionless protocol. And what it means by this is connectionless, it doesn't care about setting up a connection prior before sending. Unlike TCP does the three-way handshake, which we discussed last week. It just sends basically best effort delivery, just like UDP, but IP is also considered as a reliable, well, sort of in terms of, and it leaves the TCP header in order to make it reliable. So basically, the IP protocol is also known as best effort protocol. It's not really that reliable, but in terms of the reliability, it uses TCP. You understand the transmission control protocol at that layer for sequence numbers and snacks and acts to make the protocol in itself and it will have some degree of reliability, but in its essence, the IP protocol is not reliable. Period. IP is also concerned it's only concerned with getting the packets to the right network, and that's it. The best part determination, we'll talk about the tale of two PCs. The best parts, it will go whatever it needs to go in order for the IP protocol, in order to get to the best part. And if the IP protocol was so lost, this is where TCP now would come into play. That is why they call the concept of TCP IP, Transmission Control Internet Protocol. So TCP is going to be responsible for resending lost IP packets, basically. So the network layer header specifies the network addressing. And when we talk about network addressing, we're talking detail in terms of the source and the destination IP address, as we would see later down in the tale of two PCs. So in the transmission control protocol, what we discussed the last time with the protocol data unit basically is considered as segmentation. They'll add the IP header to it now as encapsulation of the IP packet is going to take place, and we introduce our new word now in encapsulation. So basically, what are the the understanding basically of the IP protocol or the characteristics, as you say? Number one, it is connectionless. It does not need a connection to establish a connection. Best effort delivery is unreliable, no overheads. Actually, TCP will be in charge of those overheads. Media independent, very important. Operates independently of any media. So it could go through fiber optics, could go through Ethernet, it could go through radio waves. It doesn't matter. It is media independent. So the story begins. Along the packet travels across the internet. The source and destination IP address never changes. The MAC address will change as it goes from router to router, but the source and IP address will never change. And I want you all to take note of that. The Internet Protocol is a special protocol that we call a routed protocol. Now, there's a difference between a routing protocol and a routed protocol. And in your IT career, you're going to learn about routing protocols like RIP and OSPF and so on that we'll discuss in network management one, and I advise everybody who's doing this class now to take network management one in the next semester, so it will be like a flow. All right. And IP now is considered as a routed protocol. And the reason why it is a routed protocol is because it uses what you call a hierarchical addressing scheme. And we're going to talk about hierarchical addressing scheme because this means the entire aspect of the internet protocol, is the entire aspect of the whole networking course, the entire aspect of the whole CCNE and so on, for you all to understand the difference between the network portion and the host portion. It must be differentiated between the network portion and the host portion. So, an analogy is like this: you cannot just say you have John Doe. We need to know exactly where John Doe live, with the city, his zip code, if you have a zip code, the area that he lives in, and so on. So it's hierarchical. So that part where would be the area, the city, you understand, the street that he live in would be known as the network portion. And the host portion will be is the exact number of the house that John Doe is living in. All right. So the story continues with the IP protocol, where we're looking at different aspects now of the internet protocol, and we're looking at class C addressing, and we'll talk about class A, B, and C in a little bit, or later on, probably in another video. So we are looking at class C, which starts at 192, right? 168, 1, in this case, 1.108 and a slash 24. So when we talk about the addressing schemes, what we mean by slash 24. So class A have slash 8, class B is slash 16, and class C means slash 24. So we'll do a slide explaining in detail the difference between what is a slash 24, a slash 8, and a slash 16. So for now, we just want to just understand this limited knowledge that we have here, that we are showing the difference between a network portion and how the slash 24 comes about, the difference with the host portion. So the network portion, basically, we're going to talk about subnet mask, which we're going to look at in the next slide. So in this aspect now, the red portion here is considered as the network portion, where the street, the city, the country that he lives in, and this is the street number here, which is the host portion, 108. So we talk about the concept of subnet mask, and this here is a class C subnet mask, as it defines as 255.255.255.0, because it comes with 4 octets in it. So the 255.255.255 would show the network portion, and the .0 would consider as the host portion, and we will discuss this in detail as we go along our network career. All right. So in a typical IP addressing scheme here, we have 192.168.1.111. So the 255.255.255 as 192.168.1 here considered as the network portion, and the host portion that is in green is considered as the host portion on your net mask as well as your IP addresses. And when we do the tutorial on the process of ANDing, we will understand how it is that we arrive at the host portion versus at the network portion. All right. So again, the first part of the address is considered as the network portion, this portion here, and the host now is considered as the last portion here. But bear in mind, both your network address and your broadcast address, which is this one here, your broadcast address would be your last number on that network, and your host address, so your network address will be 0. We'll talk about network and broadcast address when you go to network management 1. Those are addresses that you cannot use on your network. Those are considered as your network portion or your network address, and the last IP address on that concerning on that particular subnet is considered as your host, as your broadcast address. So basically, you could only use IP addressing from point 1 to 254. You cannot use 255 on a C portion, and you cannot use 0 on the C portion. We'll talk a little bit about class C portion, where the first number considered as network, the last number on that class C portion considered as the broadcast, and neither of them you could use in your router, you understand, to actually use as a network address. Just bear in mind, because this thing will be very confusing, but all this we're going to clear up in a little while. All right. So the thing about understanding the subnet mask, you have to understand the difference between the dotted decimal notation, which is written as in 255.255.255.0, and you must be able to convert this into binary. So basically, when we talk about place values, when we talk about place values here, 8 digits here that make up 1 octet. When you add up these things using the place values, and we'll talk about the concept of place values, it will come up to 255. Same thing, it is 8 octet, meaning that ones and zeros means all these numbers are on, so they will known as considered as the 255, and these are what we consider as dotted decimal notation. So we're going to get onto the whole concept of dotted decimal notation versus the binary conversion and so on, because in this class you have to learn how to convert binary to decimal, decimal to binary. All right, so basically this here is the decimal version here, dotted decimal version I like to refer to it, and this here is the binary conversion. All right, in the next slide we're going to talk about how we're doing these conversions. So basically, when we look at the address schemes of /24, it means then that this octet is 8, this octet here is 16, this octet here is 24, and all these zeros here showing out the 24 portion. So the first octet will be considered as /8, the second octet will be considered as /16, and the third octet will be considered as /24. That's why we can do 24. And if you count it up, it will be 8, 9, 10, 11, 12, 13, 14, 15, 16 dot 17, 18, 19, 20, 21, 22, 23, 24.0000 in this case. So this is considered as a Class C address here. Class C means /24, meaning that these first three octets here is considered as the network portion, and this portion is considered as the host. And we'll get into detail as we move along. All right, so these are some of the networking layer protocols that that you could read up on: IP version 4, IP version 6, ICMP, Internet Control Message Protocol, IPX, IPsec, Apple Talk, and so on. These are just some of the stuff that you could look in the slide to get more information. And these things, you don't really need to know them into detail. These are just definitions. All right. So some of the network layer protocols that we're going to be looking at is IP version 4 for this course here. We'll talk about IP version 6 and so on as we extend our knowledge in networking, as we move into network management 1, network management 2, routing protocols, the other classes and so on. And I advise most of you all to get into the whole networking degree, because you will learn a lot in terms of how to configure networks. All right. But we'll take a pause before we get back to the IP version 4 and talk about how networks are divided. Networks sometimes are divided through geographic, through purpose, and through ownership. And let's take a look at all of them one by one. So geographic, we have a campus in North Port of Spain. We have one in South. That one in South is South Campus. We have one in the East, which is Grande Campus. So sometimes you would divide a network through geographic notation, geographical location and so on. Then we will divide the network through purpose, that you may have artists in one network, salespeople in another network. We might have a different group of people like students, lecturers, and so on. So sometimes they divide the networks, and this is for those who do network management. One in the next semester, we're going to look at the whole concept of subnetting and putting these into different networks and so on. And then we have ownership. So we have those like the public websites, right? And we have like the corporate in like the inside. So you have to be careful, you'll have to have firewalls that going out when it's for the public domain. And then when there's ownership in terms of that, you wouldn't have a firewall, because this is we own as the slide dictates. All right. Now, wow, this is a big topic here, default gateway. And I think I'm going to have to actually literally explain this when we get to the tale of two PCs, what it means by the default gateway. All right. And what is the default gateway is useful. All right. So let me see. All right. Look, the tale of two PCs here. So here it is. We have Bob here and Sally. Right. And they want to get over to this server here on this network here. This is probably the best example to talk about what we consider as the default gateway. So it is that Bob here send a message to Sally using an ICMP message request. So you send a ping command and they ping 1.11. Right? The two of them on the same subnet, 10.1.1.10. So here have the .10 host, the same network. As you can see, 10.1.1 is the network portion, and the two of them have two different hosts. So this is .10 and this one is .11. So Sally decides to ping Bob And Bob now is .11 and sends back a message stating via the three-way handshake, yes, we communicate on the same network and so on. And Bob does the same things and they continuously ping each other, because what happens is that Bob and Sally is actually on the same network portion. Now, what happens though that Sally now or Bob here decides to ping 10.5.5.100. So in the internal network, the packet is going to look for 10.5.5.100. And the packet would have realized that in its internal network, it doesn't have that number. And its internal network, because number one, 10.1 is the network portion of this network, but 10.5 is not in this network all entirely. There's a whole different subnet all entirely. So what would happen is that that packet would have searched the entire network and realized it did not find 10.5 network, and it would carry it now to the default gateway. And the default gateway is 10.1.1.1, which is this router address, right? So the default gateway basically would be this number here, because of the fact is it couldn't find within this network, it would send the packet to the default gateway. So on the default gateway, when it reaches here now, it is going to now broadcast now throughout the network. I am searching for 10.5.5.100. Do any one of you here have a path to get to 10.5 network.5? This router now, router 10.2.2.2, would say, yes, I know somebody who knows the 10.5.5 network. Send the packet to me, and I would be able to get it across to this network. So what would happen here? The packet now would come here, and it will keep its both source and destination IP address, which is source destination IP address is going to be 10.1.1.10, and the destination IP address will be 10.5.5.100. But what would happen is that it is going to take up the MAC address of this router, and it is going to change it is as a process of encapsulation and decapsulation into this router, and picks up the MAC address of this router in itself, but the IP address will remain the same, right? So when the packet reaches here now, and they jump into the hopcon, we'll talk about the whole concept of hopcon when we get into network management one. It will broadcast here now and say, I would love to send 10.1.1 to 10 to 5.5. Can you assist me? And the packet will come to this router, and the router say, yes, I know, because within my routing table, I have a network that has 10.5.5.1. Send it to me, and I would send it across to that router that has that routing, has that IP address in its routing table, and it will go along same thing, pass it on to this one, and when it's reached now, here's the default gateway of this network, and it will send it straight into this network in onto the thing. And this is how the internet is normally work now. So basically, the default gateway is when you trying to communicate with a network that is outside. You understand? As you can see here, the default gateway is this router interface here. We are trying now to get to outside of the network, because within our internal network, we do not have, you understand, this IP address. So the router now would communicate with other routers on the internet network, you understand, or on the network or on the internet, to get that packet traverse across to that network. And TCP would maintain the three-way handshake for each one of them, while IP now will keep on jumping from router to router, best effort delivery to get to that particular server in order to get information from them. And when it reaches across here, the three-way handshake would take place. It will send back a ARC, and then it will send back a sync, and then they will start transmitting data. And that's always get information coming down on your web browser. All right, so for example, this is a typical example of two networks here. We have a router that is in between the networks. We have on this side is .5, on this side is .1. So as you can see, 192.168.1 is the network address on this side. So basically the default gateway here will be 192.168.1.1 on this router interface. And then default gateway on this side here will be .5.1, because this network here is 192.168.5 dot zero. So this is 192.168.5.0 network, and this is 192.168.1.1.0 network. And we're going to explain that in more detail as we move on to the other sections of this course. Right, so we're going to talk a lot about the coming back to the concept of /4. We're going to have to talk about the classing, addressing the class A, class B, and as well as netmask, for you to have a stronger understanding of what networking is and how IP now is a very strong topic that you need to understand.